All right, here we go. Advanced Math 8. We've got Pythagorean theorem and triples, specifically Pythagorean triples. All right, so you've probably seen the Pythagorean theorem before. So the Pythagorean theorem is named after Pythagoras, this guy like 2,500 years ago who had kind of like a math cult, kind of. But anyways, one of the things that we know that he's been credited with, even though a lot of people understood right triangles before him. But anyways, we're crediting him with the idea that in a triangle, the sum of the squares of the legs equals the squares of the hypotenuse, which is kind of a weird thing to say, but here's what he discovered. Like, let's say that this side is like 3, and this is 4, and this is 5. So what he discovered in a right triangle, which is pretty important, right triangles are super important because like then you can make like walls that are straight up and down instead of like tilted so that they kind of stay up. But anyways, what he noticed is he kind of looked at it and he said, okay, if I take and turn the sides into actual squares, so if I took this side and turned it into squares, if this side was 3, we'd have 9 squares inside of there, right? And then if this side was 4, if we change that into squares, we'd have 16 squares in there. So I got 9 squares over here, 16 squares over there. And Pythagoras said that what he called the hypotenuse, oh, that's really bad. 1, 2, 3, 4. Okay, so I got 5 by 5 over there, so that's 25 squares. Well, 16 plus 9 is 25. So the sum of the squares of these legs, these two are called the legs. If you add up the squares of this side and the squares of that side, they always equal the squares of this side called the hypotenuse. So that's the hypotenuse. So today we basically just say that a squared plus b squared, so this side squared, so here is the squares, plus this side squared always equals the hypotenuse squared, this side over here squared. So anyways, A and B are legs. These are the two sides that touch the 90-degree angle. They're interchangeable. It doesn't matter which one's A, which one's B. C is always the hypotenuse. That's the longest side. It's the side that doesn't touch the 90-degree angle. So here we go. In a right triangle, A is 6, B is 3. So we're going to use this formula A squared plus B squared equals C squared. So we're going to do plug in 6 squared plus 3 squared equals C squared. So this is 36 plus 9 equals C squared. 36 plus 9 is 45. All right, and what we're going to do is to undo squaring. The opposite of squaring is square rooting. So I'm going to square root both sides, and I would get C is equal to the square root of 45. We're not going to worry about the negative square root or the negative answer. We're just going to look at a positive answer since we're talking about a triangle. Okay, and then we've also said in a previous lesson, you need to learn to reduce your radicals because this isn't a perfect square here. So if I would take root 45 and split it up, 45, not 9. I would split it up into 5 times 9, and 9 is 3 times 3. So I've got a pair of 3's with a 5 left over. So as a reduced radical, this answer would be 3 root 5. Next one. In a right triangle, A is 10 and C is 2 root 34. Find B. Okay, so I'm going to do A squared, so 10 squared plus B squared equals C is 2 root 34. Squared. So 10 times 10 is 100. When I square this, 2 times 2 is 2. No, it's not. It's 4. And then root 34 times root 34. Remember, squaring takes away the square rooting. So this is 4 times 34. All right, so 4 times 34, let's see, 34 times 2 is 68, and 68 times 2 is 136. So I end up with 136. Okay, so we squared the 2 and we squared the root 34 just like we did in the previous lesson. Okie doke. So I subtract 100 from both sides. I get b squared is equal to 36 because I subtracted 100. And then I take the square root from both sides to get b by itself. And the square root of 36 is 6. All right, a Pythagorean triple is combinations of a, b, and c in a right triangle where all the values are integers, meaning all the values are whole numbers, like no fractions, no decimals. I guess I shouldn't have said integers. I should have just said whole numbers because we can't have negatives. Anyways, moving on. All right, so a 3, 4, 5 is a Pythagorean triple because 3 squared is 9, 4 squared is 16, and 5 squared is 25. So 9 plus 16 is 25. So 3, 4, 5 are 3 whole numbers that fit the Pythagorean theorem. The 3 would be the leg, this would be the other leg, and then 5 would be the hypotenuse. 5, 12, 13 also works. 5 squared is 25. 12 squared is 144. 13 squared is 169. And 25 plus 144 is 169. So these are 3 numbers that fit the Pythagorean theorem, and all 3 numbers are whole numbers. Notice up here, we weren't getting whole numbers all the time. We had 6, 3, and then 3 root 5. So that's not a Pythagorean triple. Over here, we had 10, 2 root 34, and 6. So that's not a Pythagorean triple. So these are values where we're always going to get whole numbers that fit in the Pythagorean theorem. These are the 2 most common that you'll see like on tests and the SATs and stuff like that. You'll see these a lot. These other ones are a little bit less common. 8 squared is 64. 15 times 15 is 225. And then 17 times 17 is 289. And 64 plus 225 is 289. 7, 24, 25. 7 squared is 49. 24 times 24 is 576. Oops, 76. And 25 times 25 is 625. So 49 plus 76 is 625. So that works for the Pythagorean theorem. So the Pythagorean triples are really just shortcuts that help you solve problems really fast without breaking out the Pythagorean theorem. So you're going to need to memorize these triple patterns that we see here. Now the nice thing about the patterns is once you have a pattern, you can make new patterns from these patterns. So for instance, if I multiplied all these values by 2, I would have 6, 8, and 10. That's another triple. 6 times 6 is 36. 8 times 8 is 64. 36 plus 84 is 100, so 10 squared. So that works. And that works for all of these. So 6, 8, 10 is a Pythagorean triple. There's an infinite number of Pythagorean triples. These are just some of the common ones I wrote down. There's a whole bunch of other ones. So 6, 8, 10 would be a new pattern that I could make off of a 3, 4, 5 triangle. I could do 10, 24, 26. That would be a new pattern that would work because I'm just multiplying these by 2. 16, 30, 34 is a new triple pattern. 14, 48, 50 is a new triple pattern. And you could keep on doing this. I could do another pattern with 3s. So 3 times 3 is 9. 4 times 4 is 12. 5 times 3 is 15. 81 plus 145 is 225, so it works. So I could get another pattern here, 15, 36, 39. This one would be 24, 45, 51. This one here would be 21. Oh man, what is it? 72, 75. So I could keep going and keep on making triples forever. What I really suggest that you do is memorize these base patterns, and I'll show you how you can still solve some of these other ones if you've just memorized the base patterns for it. All right, so let's practice that. So here I've got example 3. I've got 60 and 144, and they are sides of a Pythagorean triple. So we know there's some kind of triple. Find the third side and identify if the third side's a leg or a hypotenuse. So I've got 60 and 144. I don't know if 144 is the hypotenuse or another leg. I don't know. So how am I going to use triples to solve this one? Well, this is obviously not one of my patterns that I see here. It's not 3, 4, 5. It's not 5, 12, 13. It's not 8, 15, 17. It's not 7, 24, 25. So what am I going to do? Well, first I'm going to look at it and see if I can find a common factor inside of here. So is there a number that both of these are multiplied by? Do you see it? 12 goes into both of these. See, this is 5 times 12, and this is 12 times 12. So this number here is 5 times 12, and this number here is 12 times 12. Now it looks like one of my patterns. 5 and 12, there is a pattern for 5 and 12. It would be a 5, 12, 13 triangle. So I've got 5 and 12, so 13. So what this is suggesting to me is that the other number, I got 60, 144. In the pattern, the other number would be 13, but all of these got multiplied by 12, so I would multiply 13 times 12. So 13 times 12 is 156. So this is a 60, 144, 156 triangle. And 156, since it's the largest number, is the hypotenuse. So basically what I did is I took my two original numbers they gave me. I knew it was a triple. I figured out what the common factor in 60 and 144 was. It was 12. This is 60 is 5 times 12. 144 is 12 times 12. So I know that one of my patterns is a 5, 12, 13 triangle. So that means this last number, since all of these are a 5, 12, 13 multiplied by 12, my last number should be 13 times 12, 156, making it the hypotenuse. All right, here we've got another one. Doesn't look like this is a triple because we don't have whole numbers here. So we'll just use Pythagorean theorem. So it looks like this would be maybe A and B, and this is definitely my hypotenuse because it's the side that's not touching the 90-degree angle. So I'm going to do 2 root 3 squared plus root 13 squared equals x squared. So 2 times itself is 4, and then root 3 squared is just 3. So this is 4 times 3, that's 12. Root 13 times itself is 13. Because squaring takes away square roots, they're opposite operations. So 12 plus 13 is 25. And we get x squared. Take the square root of both sides, and x is 5. Next one, find the area of this triangle. Ooh, this is a little bit hard. This is isosceles. It doesn't tell me that this is 90 degrees, so I can't assume it, even though it kind of looks like it is. So I can't make that assumption. So what am I going to do here? Well, if it's isosceles, that means that what I can do is split it down the middle. And if I split it in the middle, these two sides should be exactly the same. So it's like a reflection over here between it. If I split an isosceles triangle right between the two congruent sides, we should get two congruent triangles right there. So that would mean that this side of the triangle is 30, and this side of the triangle is 30. So remember, to find the area, we need to use, the area is 1/2 base times the height. Now the base and the height have to be perpendicular to each other. So 60 is going to be my base, and this is going to be my height. So I need to find the height right there in order to find the area, because I'm going to do base times height. All right, so here I've got a right triangle on this side. I've got 30 and 34. Something looks familiar about that. I noticed that 30 and 34, 2 goes into both of those numbers. So let's look at 30 and 34. This would be 15 times 2, and this would be 17 times 2. Wait a minute, that's one of my triples. That's an 8, 15, 17 triangle. So I now know the other side is 8 times 2, because it's an 8, 15, 17 triangle. So my height is 16. And now I can do my area. Now, could you have done the Pythagorean theorem? Sure, you could have done it. You would just have to do 8 squared plus 30 squared equals 34 squared. You'd have some really big numbers, but it would work out. But knowing your Pythagorean triples definitely makes these go a lot faster. So our area for this one would be 1/2. The base is 60 down here. The height has to be perpendicular to the base, so that would be 16. Half of 60 is 30. And let's see, 30 times 16 should be 48? Yep, 48. So add a 0 to that. We get 480 units squared. All right, that's all I got for you, my friends. Math hard. See you later. Bye-bye.